All right, everyone. It's about 4 minutes after the start. Go ahead and get things started. The agenda today is pretty open. Couple things I wanted to kind of go over with everyone, and let me share the OPI page. So from a group perspective, we're still focused on the overall overview of things. We've got storage and security as security is partially defined. We have a fairly good storage API defined, and we're continuing to refine that in the live demo aspects. The other piece that we've added in here, we've got a use cases page that we've got, as well as a capabilities page. On the capabilities page, we've had a couple contributions that have been put in on that, and we've consolidated that into this list. So at some point, if you want to go out to our site and review the capabilities and see if there's anything else that needs to be added, please do so. One of the things that we need to focus on, and that'll be coming up in September, will be working through a workshop on the networking aspects. The request has been made to move that to the September timeframe, given vacations and timing for everyone over the summer months. So we're going to try to figure out a good time in September to get that set up, and we'll probably set it for at least a few 2-hour meetings, but I don't want to go over 2 hours, because at 2 hours we seem to lose everyone's concentration. So we'll focus on 2-hour increments. So yeah, take a chance, take some time and review the API capabilities and requirements section here. If you see other things that we need to add, because a lot of this is, there's a lot of it focused around the networking aspects. We need to probably add any application requirements around storage to this framework. So that will help out. Let's see. As far as use cases, we have these basic use cases that are defined. We need to start looking at some of the phases of operation, beginning with, how you go through the pre-provisioning. What are the things that have to be configured on the platform itself? Some of that overlaps with the lifecycle and provisioning group work, but we need to understand it from an API perspective. And then, of course, that initial setup where you are going to initially configure interfaces that get things set up. And then re-provisioning is primarily what a lot of the API work will be focused around, is the how you re-provision, how you change configurations, etc. So those areas we need to start doing some more delving into, and then also look at how the interfaces and the API SIM layer will interact with the SDKs, how it will interact with the CNI. I know there's been a lot of CNI work being done by the teams at Red Hat, but right now they've got some ongoing projects internally that they're working on related to this, to try to figure out how to make a clean layer that would tie into the kernel, tie into NetLink, and some of those capabilities. And I'm sure we'll get some additional updates from them as that work continues in the future. So with that, I will open the floor for any additional topics that we want to cover today. This is kind of what I wanted to go through. Is there any additional topics that people want to cover today? Joe, did you have any topics you wanted to bring up?
I'm giving everyone else a chance.
Okay. I
Um,
saw you go off mute. That's why I asked.
yeah, I figured. So have you guys thought yet in the API working group about how to rationalize the differences across DPU hardware on the DPU facing side of the APIs, the DPU infrastructure component facing side?
You
Because
mean you mean in terms of building like a translation interface that has to look at what the DPU is that it detects and then determine what the interaction is going to be from an SDK, or
yeah, so I would, yes, the equivalent of how would I pronounce it? Die instead of psi. So instead of a switch abstraction interface, a DPU abstraction interface that takes into account the fact that we've got SDKs and hardware that are somewhat different facing into the DPU. I know this topic was brought up at the start a couple of times, but have you guys had any discussion over the last, 3 or 4 months about how to deal with the fact that you may have P4, you may have fusion cores, you may have other accelerator components, you might have an FPGA on there, and that because those things are all programmable in different ways, they can present different direct register interfaces, for lack of a better term, right? Direct config interfaces of the tables and um, uh, parameter settings. And although they might be accomplishing the same result, they might do it in somewhat different ways. We know Dash is defining using P4 as the language to define the function and the API. They're primarily using P4. I don't think we agree to that, and we sort of swept this topic off into the corner a little bit. But it's, in the use case group, we just had this discussion half an hour ago, and somebody said you have to answer this right now. I still wouldn't have a good answer as to the right way to deal with the different DPU vendors under the covers, other than to say, hey, we got APIs northbound. That's how you configure the thing for what we've defined. The vendors implement however they want. Some projects implement however they want. Stuff sometimes flows back to expand the commonality, and that's how OPI sort of will grow and develop. Piecemeal and as needed. I think that's okay to get it launched, but we need an answer to this question on, do we have inward facing APIs that are comprehensive and one definition? Or do we say, nope, here's our northbound APIs, we'll let the vendors implement as needed, or it's some open source package, so it's kind of well understood because it just runs on the ARM cores. Does that topic even make sense? And if it doesn't, argue back, because if you're like, well, yeah, I understand what you're saying, Joe, but we're not gonna, there's no way to really tackle that in any public forum. Or yeah, we can tackle it, we have too much else to define first, or there are a lot of ways to respond to that, or like, yeah, it's a problem, but we don't know how to deal with it either.
So it has been an issue that has come up at least a couple of times some time back. It's more than 3 or 4 months ago that it was discussed. Basically, at the time that we discussed it, it was primarily going to be something that was part of some of the implementation work, but it wasn't going to be or there was still a decision going on around whether it was going to be something that OPI would work on or something that would be from the solution providers, right? Because everybody wanted to have their own level of IP in there. It's probably a topic that needs to be revisited and make a determination on where and how, or do we need a separate work group to be looking at some sort of abstraction interface to handle that? That's my view, at least in going through the history and thinking about what you were saying. I don't know if there's other views out there. I know from the Pensando view that their interface is primarily using gRPC and protobufs that goes into their associated layers. From Intel, it goes in through IPDK.
Well,
and go on.
So I think if we had, different protocols, we could bridge the protocols. What I'm concerned about is not so much the protocol definition, but the underlying function. So, let's take one of my favorite topics. So suppose I have, NVMe offload. And let's suppose there were material differences in the implementation that actually had to be exposed to the config interface. What's the right way to deal with that from a public consortium? I mean, what I would say is either we define a minimum subset that everyone must conform to, and we then say you can have extensions, or what you do is you try to define the maximal thing and say you don't have to implement everything. In other words, here's the required and then the optional fields, but you try to define the maximum subset for now. And if somebody comes up with a new block of config settings, you add those, and you basically say which ones are optional and which ones are required, so that you have at least everything defined. And I never know which of those is the better approach. They have pluses and minuses. I mean, Cy took the thing of, nope, here's our, here's what it is, and you don't get anything else. Except you can kind of have Cy extensions, except they're kind of painful, and then they're really non-standard and so on. Others have taken the view of, Redfish says, here's the base models. We tried to be as comprehensive as possible. Some of the stuff is optional. Oh, and by the way, you can still have extensions, but we hope you don't use them too much.
So Ben, you've got your hand raised.
Yeah, so maybe I'm digressing a bit, but I'm also coming from the use case working group and what just Joe said. Are there it might help us if we have a list of technologies, right? Our building blocks that we write and say, hey, this is a set that we need to explain. Explain may be a wrong way of saying it, or we need to explain to somebody our stance on those things. Somebody says, oh, what about P4 and OPI? We need to say what is our stance. So having a small list would help us. Then we could make them as, okay, you have a choice of eBPF versus P4 in this layer here. And other areas we could say, okay, this we don't care, you're on your own. We doesn't matter to us. And here we say, no, we are adopting Cy.P4 as our P4 pipeline. We could make such stance on each one of those things, and in a way that will describe our stack. This is the perfect topic for our workshop, right? Because if you see the knowledge that we have, I see on the screen here, I think we have enough. But if we can put that set of things that we need to explain, maybe that becomes a problem definition for us, and this group can easily solve it. I wouldn't say easily, but at least has the best chance of solving it. Does it make sense?
Oh yeah, no, that makes sense. Well, we configure up the list. We have things like Dash and Cy, right? And then we'll have IPDK, we'll have Doka, DPDK, RT flow, TC flow, Netlink. I can put Netlink in there.
OVS, OVN. I
Yep.
want to even add certain interfaces, right? And even though Chris was not there, in the other meeting, I did mention Chris Sommers, who is leading the API, P4 API working group on some table-driven interfaces somewhere I feel that has certain value and things like that. So interfaces as well as building blocks that it could be across the stack. And if we make a list and then stacking them up. Yeah, I lower my hand and let others continue, I guess. Yeah.
Yeah, I wanted to add to that too, if that's okay. Sort of reacting to what Joe was saying, having some kind of a standardized API makes sense, but I hope we could avoid one of the things that Sai did is it chose to define everything as terms of C header files, which is very opinionated in terms of the implementation. And it would be nice to come up with an abstraction that isn't tied to a particular implementation. So, for example, something that's a logical table interface or some other variation, some API definition, like Open API or Yang or something that defines the entities in the interfaces without saying it's a C header file. Because some people might not do a bit of code in C, they might do it in Golang or something else. And trying to define a standardized API as in terms of a programming language, I think would be a mistake at this point in technology. It made sense in 2015, but I don't think it makes sense today. So I just wanted to add that comment.
Okay, anyone else?
Yeah, that's a good comment. Do you have an opinion, Chris, on the comprehensive and these things are optional versus the baseline with extensions? Right, because those are kind of the two fundamental approaches you can take for defining this kind of higher, HAL type API. And again, this isn't the HAL to the DPU chip itself. This is kind of the HAL to the board, because but they're both hardware abstractions. If you think about it,
I don't know if I have an opinion on whether it should be baseline plus extension or everything and everything is optional, or some things are optional. But what I think we should ask is that the target device return an answer to a query. What are your capabilities? It should, should be able to say, here's my supported list, so that some controller or orchestrator can know the capabilities and not try to ask for something it can't do, and not wait for an error message to get thrown back when it tries something unsupported. So just the basic notion of capability query, I think, is important. For example, in Yang netconf, you can say capabilities API, and it returns all the Yang, namespace URIs for all the schema that it supports. There's different ways of doing this, right?
Yeah, and you can do the same thing in Redfish by getting the schema supported by the box. So there's a meta query that returns the schema itself, and that tells you what is and isn't supported.
Yeah, so I think that's a baseline requirement, is capabilities, query.
And in fact, is that an API we should define no matter what?
Yes.
I would recommend
as a whole.
Yeah, we have inventory, but we haven't expanded it to include capabilities.
Yeah, but inventory is the hardware inventory, right?
Inventory is the hardware, the current firmware, some of the pieces that you need to do life cycle management. It's not, it might tell you that what some of the interfaces are that are out there. It'll tell you what the PCI framework looks like, but it doesn't tell you the capabilities that are available. For example, what accelerators may be available on the hardware. It won't tell you what the potential software has been, software capabilities have been loaded on there. So for example, if you've got a software load that contains a firewall, it's not going to tell you that in the inventory.
Well, there are two levels three levels at which this works. One is
Mhm.
the base hardware that you were describing. The second level is the hard beyond base hardware. So, if I have a particular set of, if I have a hardware crypto engine that has a certain capacity, certain frame, byte and frame rate, and a set of algorithms it natively supports, that would be nice to know. And again, that's a open-ended, it'll evolve in the future kind of API where you get strings back or something that tell you what they are, but every time you get a new one, you define a new string, and it's well-defined meaning for the strings. And then and maybe you run different algorithms at different rates, and so on. So that, and then the third level of it would be, what are your software capabilities? What Chris was just saying is, what are your soft capabilities? What parts of the overall schema do you support? So, do you support Strong Swan would be a good one. Do you actually support OTel delivery? And then if you support OTel delivery, what's your telemetry schema? And the telemetry schema would be, again, it's definable, and it can be both human readable and machine readable. And the human readable tells you what the things, mean, essentially comments, and the machine readable give you all the variables, so you don't have to, you wouldn't have to copy and paste or anything. You could just read the thing. And if you had again, if I have downstream analytics programs, you can dump those things into databases automatically and do some stuff without actually, sort of automatically. There are programs that do that. So knowing that you support OTel and what the schema is, so that when you connect to the OTel, you know what you're going to get, is useful, right? Same thing with the open config, right? So open config has what, 60 models, something
Yeah.
like, and knowing what set of those the box actually exposes would be valuable if we used open config, etc. So
Yeah.
maybe that's a meta API we could define that would start to unify some of the work. And again, if that's a bad idea, or you think it's way too hard to define, although I personally don't think it is, then tell me, because I'm trying to think of how this project comes together, and that meta API might be just the thing to start framing up all the rest of the pieces that are being built.
Mhm. No, capabilities is something that we have identified as it's an API that has to exist. We don't have it yet. We only have the inventory one so far.
Right. But I'm saying, what I'm saying is maybe that's one that can bridge over the lifecycle and provisioning group as well. That would be, a useful one to define. And I suspect everyone could get behind implementing that one. That one wouldn't be too bad to implement across all the vendors. And at least that you could, and even if just for not diagnostic purposes, but even just for, oh, that's what that thing supports purposes, it might be useful.
Yeah.
Right. Even if it was a black box, even just that API done in common means you could query, you get your inventories, you get your baseline, you get your, and then you get your hardware capabilities and your software capabilities returned, and you can just, even just to know what you actually have in a setup, after the fact is not trivial, right? And instead of scrambling, if you have a clean API, that by itself has value. Because I know debugging stuff, I'm always asking, so what exactly do you have in there? And a lot of times people go, oh, I guess I have to double check, right? Because they get used to not thinking about that stuff.
Mm-hmm. So Venkat, you got your hand up again?
Yeah, so I may be peddling common sense and stop me. I just coming off of another discussion, building another stack. one of the realizations, even though it's common sense, occurred to me is that if you're building a stack and there are like, at lower layer, different kinds of, technologies, capabilities, there are few layers that we could skip in the beginning to get into details and say that, hey, don't get into whether it's implemented as P4 or not, and jump into the higher layers in a way top-down approach, right? But you do need to have a high level functional API sets or feature sets. But how they get implemented, if we could put aside for a while, that could help us converge and move forward. But at the same time, you do need to look at the lowermost layers, which is, hardware capabilities. What is the baseline? I mean, almost like, is it SI.P4? But even that can be made optional. So again, I'm just thinking in terms of how do we move forward, and then we may end up with APIs at multiple layers. Recalling how we've been presented a while back on is it object layer APIs or functional API on top, right? So skipping some things in between, going to capabilities at the lower layer, high level functional sets on the top would allow us to move a little faster.
Okay. I'll call out. I'll ask Vipin, since he's one of the vendors that's here. Does that make sense, Vipin, to do something like that?
Yeah, so I mean, my opinion is that we are having lots of discussions on what layering is right and how do we program certain things, and different DPU vendors have different capabilities, and that's how we are starting. But what we are really lacking is contributions. So that's why we started off saying, okay, let's have people contribute to whatever level and things that they are comfortable with. In other words, I mean, if you want this API to satisfy your use case, presented. If you bring in enough use cases, there's plenty of market. We can then look at what abstractions is looking right, because we know various abstractions. We know where to cut the boundary. We know how to homogenize things. What we are lacking, in my opinion, is the actual code. And more code comes in, the better it is for us to wrap our mind around what is common and what satisfy the users of OPI. Because ultimately, users of OPI are going to be people who are justified by some business case at the end of it, which means if there is revenue, people will implement it. And therefore, I think instead of trying to have one common thing right from get-go, which we could if there was a very clear thing, but since I've been involved, I'm not seeing one common API being, at least for networking. For storage, I think we have a decent shot at it with implementations from all DPU vendors. So I'm pretty comfortable with storage APIs, but networking APIs are the ones I'm talking about. So let's have the use cases that people want to bring on with code, incorporate that, and then we circle back on this question on what layering is right to have multi-DPU solution. The reason Dash is gaining momentum and popular is because there is a user that is sitting behind it. And that user is saying, hey, if you implement these APIs, I'll buy it. And if people implement those APIs, and if they get to justify the business case, of course, people will implement that. They may have some discrepancies here and there, which either they have to accommodate or recommend the changes for whatever the case is. But at least we are moving in direction where there is going to be more justification internally within the companies. So I would say that, let's bring in more use cases based contributions And then we come back to this question because we can endlessly discuss the layers and it's very clear in my mind what those layers are. It's very clear in probably other people's mind also. The thing that we are unsure about is what is right, and let the flow of business decide what is right. And then we come back to like, hey, you know, these use cases are the most popular with OPI. Why don't we standardize on these things and call it a multi-DPU solution? I'm just thinking out loud since you called me Mark. I don't have perfect answer, unfortunately.
No,
But
that's all really good observations, Vip, and I think you're right in terms of we need more contributions. We need to address more use cases. That's why I brought up the use cases slide that we've, or I should say the page that we've got, simply because we'd like to get more contributions in terms of what are additional use cases that need to be considered in the list, and then how do we fill in all of these different use cases that we've got identified so far. So I think that aligns with what you're thinking is that independent of that, bringing up the capabilities API, I think that's something that independently we can go work on separately. But as far as the networking goes, I think you're right. We have to get more use cases defined.
It makes sense, Vipin. I'm always putting you on the spot, but I think you have insights that are extremely useful. So thank you.
I'm happy to contribute, definitely from code point of view, and I am doing whatever I can, from bringing in the code with use cases, building prototypes. I think, you know, I was just talking to Boris. Hopefully we'll also put out the AMD bridge code for storage. So finally, storage will have bridge code for all vendors. That's really awesome. I mean, that's exactly what we need out of OPI. So if we say that, okay, the OPI APIs for storage can be used across all the vendors, great. So we'll have that and also contribute the code. On networking, again, it's the entire landscape of networking is the challenge. It's not that we are incompetent here. We are all very competent people and trying to solve multiple problems with one weapon, and that's what the challenge is. And networking, it doesn't exactly work like that. We can try and align at a macro level, but as we go into the details, it'll be tricky. So I think the best is, like, you know, if someone has a business case and use case, bring it on. We'll take various contributions and then try to see where we need to standardize.
Okay, thanks, Vipin.
Yeah.
Joe, did we address what you were thinking?
I mean, yeah, I mean, I put that out there because really to get people thinking about what we should actually do for OPI. So it's good discussion, Vipin, and you know, Vin, Kat, and Chris. So really to start the conversation, not to try to derive an answer, or, you know, I had a specific question that I wanted answered today. It's more of what's going to be our plan. I mean, you have a plan for, you know, individual tactical APIs, but what's the plan for how it all comes together? And again, it's not going to get answered in, you know, the 2 minutes we probably have left for this call, or 7 minutes, or whatever, you know, whatever it's going to be, but it's stuff we have to think about.
Right.
So it was really a thinking and technical discussion starter.
Right. I think the other piece that we have to consider, in at least in looking at all these stacks, is how do we tie into the CNI layers. And I know Maryam and them have been working on that, so we'll let that continue, and then we'll try to start mapping all of that around too, because that's another element that has to be taken into account. All right, any other topics or discussion points that we want to bring up today? If not, then I will go ahead and wrap up the meeting. We'll give everyone back 20 minutes. And we can meet again next week, and hopefully we'll have more detailed topics to dig into.
Thanks,
Okay.
Mark.
Thanks, everyone.
Thanks, Mark.